You know, in our digital world, we trust countless pieces of software every single day. But what happens when that trust is broken? Today, we're going to dive into a critical and often totally invisible risk that affects everything from your phone to massive corporations. Let's pull back the curtain on how this happens and, more importantly, what it means for all of us.
Okay, let's start with something we can all relate to. Picture this. You're not feeling great, so you order some really important medicine from a trusted online pharmacy. You're counting on it being the real deal, exactly what the doctor ordered. But here's the scary part. Somewhere between the pharmacy and your doorstep, an attacker intercepts that package. They carefully open it up, switch out the real medicine for a convincing but totally dangerous fake, and send it right along to you. To you, the package looks fine. The box is sealed, the label seems right. So the big question is, how would you ever know that what's inside isn't what you ordered? This exact problem, it's happening right now, every day, but not just with pills. And that's our jump-off point, where we go from the physical world to the digital one. That risk of getting a tampered package, it's the perfect analogy for a massive cybersecurity threat we call a software and data integrity failure.
So what are we really talking about here? Well, it's what happens when we install an app or run an update and just trust it blindly. It's a failure to ask two critical questions. First, is this really from the company that says it is? And second, has anyone messed with it along the way?
I mean, look at this. The parallel is just crystal clear, isn't it? In the physical world, an attacker swaps your medicine. In the digital world, they sneak malicious code into a software update. But the solution is also parallel. For the pills, you check for a tamper-evident seal. For software, the check is something called a digital signature. You can think of it as a high-tech, unbreakable seal that proves it's the real deal and it hasn't been touched.
And believe me, this isn't just some theoretical what-if scenario. Let's talk about what happens when this goes wrong on a truly catastrophic scale. We need to talk about one of the biggest cyber attacks in recent history, the SolarWinds breach.
Okay, so how did this whole thing even happen? It's fascinating and pretty terrifying. First, the attackers broke into the software factory itself, what's called the CI/CD pipeline, the automated system that builds the software. Once inside, they quietly injected their own malicious code right into the real deal. And here's the absolute kicker. This now tainted code was then signed with a completely legitimate SolarWinds digital signature, so to the outside world, it looked totally authentic. That compromised update was then pushed out, and thousands of customers installed it, having no clue they just opened the front door for the attacker.
And the fallout? It was just staggering. Over 18,000 organizations, including parts of the US government and huge corporations, were compromised by this one malicious update. They all trusted the digital seal, but the product inside had been poisoned at the source.
So you gotta ask, how did they pull this off? Well, it really boils down to a few critical failures. The factory where the software was made wasn't secure. There was nobody watching the digital assembly line for suspicious activity. And probably the biggest reason, every customer who got it trusted the update simply because it had that official signature, not realizing the signature itself had been applied to a compromised package.
Yeah, the SolarWinds attack really just blew the doors open on some deep cracks in our digital supply chain. So let's break down the three main ways a system like this can fail.
All right, because number one is the most straightforward. Think of it as a package arriving with a broken seal or maybe no seal at all. This is what happens when developers don't digitally sign their software, or, just as bad, when our systems don't even bother to check for a signature before installing. It's basically an open invitation for an attacker to swap the content.
Because number two, this one is much more insidious, and it's exactly what went down with SolarWinds. This is when the software factory itself gets compromised. If an attacker can get inside those automated systems that build the software, that CI/CD pipeline we mentioned, they can inject malicious code before the official seal of approval is ever applied. It's an inside job.
And number three, we're talking about untrusted ingredients. You have to remember, modern software is built using countless third-party components, kind of like ingredients in a recipe. If you don't check where your ingredients come from, you might unknowingly use a compromised library from a public source, baking a vulnerability directly into your own product.
Okay, so that sounds pretty bleak, right? All these weak points. So how do we fix this? How do we actually build a system that we can trust? Well, the good news is there is a clear prescription for improving our digital security. It all comes down to three fundamental principles. Ready? 1. Sign everything. Every piece of code, every update, every package needs a digital signature. No exceptions. 2.
Verify everything. It's not enough to just sign it. You have to check that signature every single time. And 3, secure the entire pipeline. You have to protect that software factory from the inside out. Now let's see how those principles translate into actual practical techniques. For sign everything, the solution is using strong digital signatures on all software. For verify everything, a key tool is what's called a software bill of materials, or an SBOM. Think of it like a detailed ingredients list for your code, so you can track every single component. And finally, to secure the pipeline, you need robust security on that build system itself, things like strong access controls and audit logs. It's basically like having security cameras and keycards for the software factory, so you know exactly who is doing what and when.
Now, I know this might all sound like a problem for big tech companies to solve, but the principles of verification and trust, they apply to every single one of us.
So here's the bottom line, the crucial takeaway. Blindly trusting digital information is a massive risk. The core warning here is that if you accept software or data without checking its integrity, you are essentially handing the keys to an attacker without even realizing it.
And that brings us right back to the beginning. From the apps on your phone to the browser plugins you install, we all accept digital packages into our lives constantly. So the final question I'll leave you with is this. What are the unchecked packages that you're trusting? And how can you be sure they haven't been tampered with?